Hello everyone. Today we talk about circuit breaker pattern. So let's start with definitions. So it's a fault tolerance design pattern that prevents cascading failures in distributed systems by monitoring for failures and temporarily stopping request to a failing service. So we've got here two important moments that first of all we monitoring for failures first of all, and we temporary stopping requests. So it's like two keys here. So this gives the downstream service time to recover while protecting the calling service from wasting resources on doomed requests. So okay. Next, we should talk about states we have. So in this pattern we have our like system, or how we call it, have three states: uh, closed, open, and half open. Um, so closed, it means that in closed state, all our requests like flows normally, so nothing wrong happens, and so the open states occurs when we detect too many failures. So for example, we start to send requests, and so something wrong happened, and we've got like failures every time. So when we've got failure count, and after some, so when we exceeded a specific threshold, uh, we uh, so we got this open state, and so when we're in the open state, we block all requests. So for specific like time period. Next we have half open state. So after this timeout period we allowed our system to make a couple of test requests, and so and here we have like two options. If everything is okay, it so our state transitions from half open to closed, and like we work normally again. Otherwise we go to like open state, and again wait for some period of time. So yeah, that's I don't know, simple or not. uh, so yeah, and here we have like some sort of summary about it, close open when failure rate exceeded, from open to half open if timeout period. So again, mm, how we pass this timeout period, so and we go through from open to half open, and here we have this two options, like from half open we can go to open or to closed. Okay, so here I have as an example my own implementation of circuit breaker. So it's very simple, just for understanding, and so I want to show you how it works, explain you some things, and probably it will help you to understand this pattern a little bit deeper. Okay, so I have this class here, so loggers, standard things, and here we have a couple of variables, couple of fields, like state. So it's an enum. This is our states: closed, open, half open. We've got failure count. So we have last failure time. We have two threshold. So first and second. So okay, so let's talk about this two. So threshold one, in my case, let me show you. So Transition from closed to open happens when we exceeded some this count, like too many failures. Yes, too many failures. In our case, threshold 1, it's the number of failures. These failures. So if in my case, in my example, let me show you. We've got we will have 3. It means 3 times and 3 failures, and we get to open state. Next, we have this transition to half open, and from half open we have this. We will make so couple of test requests, and in my case, just one. So I set 1. So if 1 is fail, then we go to open state. So this is the logic here. Okay, and timeout, it's the time we wait when we in open state. Okay, so next what do we have? So the main method here is execute. Let's see. So here we have this logic. So let me show you. If okay, let's start with this. So when we in open state, we must check if so time exceeded means that so yeah, we've got our timeout here, and if this time like passed, we just switch to half open state, and we reset failure count to 0. So this is the first case, and and here's the important moment that you see if it's if this time isn't exceeded. In that case, we give this how to say it, fallback. How to say it? Well, we invoke this fallback method here. Let's say so. And so we return. Yeah. Okay. So we return fast. So-called fast failure. What does it mean? It means that instead of trying to, so when we in open state, so our system still works. It's very important. So, but instead of like trying to call this like real method or some sort of REST request, we just give some sort of like default answer every time, without trying to do something. Just while it's open, just give fast failure. So, and do not execute this main operation method. And yeah, so this is an important moment here. When we in closed or half open state. So let's see, we'll get here, and whoops. So if everything is fine, and we in closed or half open, in this case, we just set state to closed, and failure count to 0. So we'll reset everything, and like we in a normal flow state, let's say. If something went wrong, so we've got failure. So let's see. In this case, I've got here this logic. So first of all, we will increase failure count. So we have to monitor this count. Next, we will have last failure time. So we need this parameter to understand how many times pass since last failure. And here I have two conditions. If one of this condition like true, we will put our state to open. So let me just show you this picture again. So either we in closed or in half open. In both cases, we can have as a result open state. So through different conditions. So first condition here. So if we in closed state and we exceeded this threshold, so in my case, in our examples, it will be 3. So in that case, it will be open state. In case of half open, I've got another threshold, and yeah, so in my case, again, it's 1, and yeah, again, we will get to open state if something went wrong. Okay, so actually this is it. So let's see my logs here. I've got a couple of logs. So okay, first of all, this one, so we can see that this specific invocation, we can see I've got here this like some sort of marker in my logs, like my circuit breaker, so we can see that this is so this is specifically happening inside our circuit breaker. Okay, current state, different these things like failure. So like if we return fast failure, so we've got this log here, transition from open to half